Um, Good day, everybody. Welcome back to my channel. The last video we went over one of the applications of differentiation, and that was rate of change. Today we are going to go back to that differentiation. That's an introduction to derivatives for economists. So, firstly, what exactly are derivatives? Derivatives measure the instantaneous change of a function at a point. So remember, in rate of change, we're measuring the instantaneous change of a function with respect to a change in time. But derivatives are quite different. They are like the gradient change we talked about in the last video. They measure instantaneous change of a function at a point. So why do economists use derivatives? It's because derivatives are very accurate tools to measure change in economics, and economics we are very primarily concerned with a lot of change. For instance, um, let's take a firm. For example, let's say we have a firm. Let's say the firm's cost function is C equals 5x, where C is the total cost and x is the output or quantity produced. So how do we measure how much their total cost will change whenever they employ and or whenever they produce extra output or units of goods slash services? So differentiation is a tool that can help us, get the value or a very straightforward answer to this. This function is basically telling us the total cost that the firm will incur if it produces x unit of output. So if you want to measure how much that cost changes per unit of output produced, we use what? We use derivatives. So that's why economists use derivatives. It's not only in cost, we also use it in revenue, we use it in products, calculate marginal product. So how exactly do we do derivatives? Very simple. The general formula for derivative is x raised to the power n. Here, let's say this is a function like this. So the derivative of x raised to the power n is just equal to n, that n comes to the back, times x, then raised to the power n minus 1. Do you understand? So let's take this function as an example. So we have c equals to 5x, right? So if we differentiate this function with respect to output, so that would be d over dx, right? Our dc by dx, that's basically how much their cost changes with respect to a change in output produced. That's just going to be, remember this is 5x raised to the power 1, right? So if 1 comes to the back, it becomes 1 times 5x raised to the power 1 minus 1. So dc by dx is just going to be 5x raised to the power 0. Anything raised to the power 0 is 1. So dc by dx is equal to 5. Now, what is the interpretation of this value? This value is a constant, that's 5, constant of 5. This means that for any amount of output that this firm produces, their total cost increases by 5. Let's take an example. Let's say the firm produces 1 unit of output, right? So C is going to be equal to 5 open bracket 1. So their total cost is going to be 5. Let's say 5 naira. Let's take another example. Let's say they decide to produce 10 units of output. So C is going to be 5 times 10, and that's 50 naira, and so on. So that's basically the whole concept of differentiating. So let's take another example. Let's say we have a total revenue function, like let's say a firm's total revenue function. That means the total amount of money they gain from the sale of goods and services. Let's say the total revenue function is equal to 40q squared. Now you see this one is quite different from this because this one is linear, the cost function is linear, and this one is exponential. This means total revenue will grow faster than output produced. Why? Because of the presence of exponents raised to power 2. So how do we find out how much their revenue will change if their output changes? Very simple, we differentiate. So when we differentiate this with respect to quantity, we have dTr by dq. Remember, change in total revenue with respect to a change in output is going to equal the same process. 2 is going to come to the back. Remember this formula, times 40 times q raised to the power 2 minus 1. This is going to equal 2 times 40 is 80, ATQ. 2 minus 1 is 1. So this means per unit of change, or for every output that the firm decides to produce, their total revenue will increase by 80 times that output. So let's take an example. Let's say the firm decides to produce um let's say 10 units of output. Let's try that. So TR is going to equal 40 open bracket 10 squared, right? So their total revenue is just going to be equal to 40 times 100. This is just total revenue is just going to be 4,000 naira, and so on. So that's basically the whole concept. And one thing you should remember is whenever you hear the word marginal in economics, you should always think derivative. Marginal, derivative. Marginal, derivative. So in any form, in any question where you're asked to calculate the marginal whatever of something, always just know that they're asking you to differentiate or find the derivative of that function. If they ask you to find the marginal revenue, the marginal revenue, marginal cost, or marginal product, the first thing that the only thing, the first and only thing that should come to your mind is derivative, because that's basically what marginal in economics means: extra or a unit change, and that change is basically what derivatives offer. So whenever you hear the word marginal, or whenever you see the word marginal in any question, just know that they're asking you to differentiate that function. Okay, so we have some practice questions here. So the first question says, or we have a function, the total revenue function of a firm, to equal 75Q minus 4Q squared. How much will revenue change when output changes? This one is very easy. They're asking you to find the marginal revenue, or a marginal revenue function of the firm. That marginal revenue function means how much their revenue, or the revenue they will gain, will again the firm will like earn, will increase when they increase output by a unit. For instance, let's say a firm is earning, let me just do a quick scribble here. Let's say a firm earns 100 naira when they produce 10 units of output, right? And they increase the output that they produce from 10 to 11, and their revenue increases from 100 naira to 120 naira. So they end, so by implication, they earn 120 naira revenue from producing 11 units of output. So what exactly is the marginal revenue here? It is the change, or the difference between how much they earned before the increased production. So basically that's just 120 minus 100. So their marginal revenue, that's the extra revenue they gained from producing an extra unit of good, is 20 naira. So that's basically the whole concept of marginal. The same thing with marginal cost. Let's say they incur a cost of 100 naira when they produce 10 units of good. So when they increase the amount of goods they produce to, let's say, 11, and their marginal, then their total cost increases to 120. That means the change in cost after they increase output by 1 unit is just 20 naira. That means they incurred a cost of 20 naira from the production of that extra unit of goods. So that's basically the concept. So here we have a function. We have a function, we don't have actual numbers. It says, how much will revenue change when output changes? This one is just basically asking you to find the derivative of the function, or the marginal revenue function. Nothing too serious. You are only required to differentiate this function. That's one of the ways in which we apply derivatives in economics. When you differentiate total revenue, you get marginal revenue. When you differentiate your total cost, you get marginal cost. When you differentiate your total product, you get marginal product, or marginal productivity. So that's basically the whole concept. So whenever you hear marginal, think derivative. Whenever you hear change, think derivative. So that's basically it. So let's differentiate this function. So when we differentiate this function, we get dtr over dq. This is basically saying change in total revenue with respect to a change in quantity, or you can write it as your marginal revenue. So remember, whenever you hear marginal in economics, think derivative, think differentiation. Whenever you hear change in economics, either be your change in output, change in revenue, change in cost, think differentiation, think marginal. That's basically a simple hack. So it says, how much will revenue change when output changes? Simple. You just differentiate this function. And if you remember the rule of differentiation, this one comes to the power comes to the back, then minus 1. So since this one is 75q raised to power 1, it just becomes 1 times 75 times q raised to the power 1 minus 1. Then minus the same thing for this, 4 times 2 times q raised to the power 2 minus 1. Very simple. So your change in total revenue with respect to a change in output, or your marginal revenue, is equal to 75 times 1 is just 75. And then q raised power 1 minus 1, or q raised power 0. Anything raised power 0 is 0. So we have just anything raised power 0 is 1. So just 75 times 1 minus 4 times 2, that's 8. 2 minus 1 is 1, so we have 8q. So your marginal revenue, or the firm's marginal revenue, is equal to 75 minus 8q. So the interpretation of this is that whenever the firm increases output, or increases output by a unit, their marginal revenue, or the extra revenue they will incur, or sorry, earn, will exactly be 75 minus 8 times that the number of goods they produce. So let's take an example. Let's say the firm was earning total. Let's say let's plug in some values to make this more like practical. Let's say when the firm produced, let's draw a line, produced the no, we have total revenue to be 75q minus 4q squared. So let's say the firm produced 5 units of output, right? So their total revenue will just be 75 times 5 minus 4 times 5 squared, right? So total revenue will just be okay, sorry for the pause. I had to go and get the calculator. So the total revenue will just be 75 times 5, that's 375, minus 4 times 5 squared is 25, so we have 100. That's 25 times 4. So the total revenue the firm earns is just 275. Let's say this is Naira. So this is the total revenue. So let's say the firm decides to increase output from 5 to 6 units. What will be the margin? What will be the change in their revenue? Like, what will be the extra revenue they will gain from expanding output? That's what this function here means. This function here will help you to determine the numerical value of how much revenue, or how much extra revenue they will earn if they expand output production. So we can just use this one to get how much output they earn, extra output. So the MR, or marginal revenue, is just going to be 75 minus 8 times how many units did they produce? 6. Do you get? So their marginal revenue is just going to be 75 minus 8 times 6 is so 8 times 6 is 48. So the extra revenue they earn from producing an extra unit of good, that's from 5 to 6, is just going to be 75 minus 48. So the firm earned an extra 27 naira from expanding production from 5 to 6 units of output produced. That's basically what the interpretation of this is. So let's take the next question to understand better. So this one is cost. It says a firm's total cost function is TC, total cost, is equal to Q squared plus 7Q plus 23. How much will cost change when output changes? Same thing with this, just differentiate it. So our DTC by DQ, let me change the marker, this one is fading. So our DTC by DQ, or your marginal cost, is equal to, differentiate, 2 comes to the back, 2 times q raised to power 2 minus 1 plus 7 times 1 times q raised to power 1 minus 1. Then, remember the derivative of a constant is 0. Why is that? Let me draw another scribble here. So we can infer that we can rewrite any constant. Let's take an example. Let's say 5, right? This 5 is equal to 5x raised by 0, or 5y raised by 0, 5 whatever variable raised by 0, because anything raised by 0 is 1, and 1 times 5 is 5. So if we differentiate it using the power rule, that x raised by n minus 1, n times x raised by n minus 1, we can infer that this will be 0 times 5 times x raised by 0 minus 1. So 0 multiplied everything here will just give us 0. That's why the derivative of a constant is 0. So that's it. Another logic to understand that better without the mathematics is that since it's a constant, that means it cannot really change since it has no variable attached to it. So 5 cannot really change from being 5. So the change that happened from 5 was nothing. So if you have a point here, 5, and that point does not move to anywhere, the change that that point experienced is 0. Since it's constant, it's unchanging. So that's another intuition or intuitive reason to why the derivative of a constant is 0. Or the mathematical proof, let's say you have 5 times x raised to power 0, 0 comes to the back, 0 times 5 x raised to power 0 minus 1. So that's just going to be always going to give you 0. So that's why the derivative of a constant is 0. So let's go back to the question. So it says the firm's total cost function q squared plus 7q plus 23. How much will the cost change when output changes? Very simple. We differentiate the function to get our marginal cost. So our marginal cost is just equal to 2q, since 2 minus 1 is 1, plus 7 times q raised to power 0, then plus 0. Right? So our marginal cost is equal to 2q plus 7, since q raised to power 0 is 1. So this is our marginal cost function. And intuitively, we can use this same system to explain or to interpret what this value means. So let's say this firm produces 5 units of output again. So the total cost is just going to be 5 squared plus 7 times 5 plus 23. So the total cost is just going to 5 squared is 25 plus 7 times 5 is 35, then plus 23. So 35 plus 25 is 60 plus 23, that's 83. So their total cost is 83, let's say naira. So let's say the firm decides to produce or to expand production from 5 to 6 units of output. How much will their cost change or increase? Very simple. Since we have our marginal cost function here to be 2q plus 7, we can plug in our values here to see the marginal or extra cost that firm will incur. So our MC is just going to be 2 times, since they are expanding from 5 to 6, 6 plus 7. So our marginal cost is just going to be 2 times 6 is 12 plus 7, that's just going to be 19. So if this firm expands production from 5 to 6 units of output, they will incur an extra cost of 19 naira, meaning at production of 6 units, their total cost will be 83 plus 19, and that's just going to be 102 naira. So that's basically that's basically what the interpretation of this means. So their marginal cost, that means when they increase production from 5 to 6 units of output, the extra cost they are going to incur from that extra production is 19 naira. That means, let's say, yeah, that's basically it. They incur 19 naira. So the total cost, this is just the cost they incur from producing an extra good. That's basically what the marginal cost interprets to. So consequently, their total cost, that means the cost they incurred from producing 1 to 5, then plus good 6, should just be the total cost plus the marginal cost. So that's basically it. So let's treat one question, then we'll treat one last very practical question. So this question says, if a firm's average cost function is AC equals 90q squared plus 6q plus 17, determine the firm's marginal cost when they decide to expand production to 15 units of output. Very simple. But looking at this question, we were not given the total cost function. We're only given the average cost. So how do we get our total cost from average cost? Since it's the average is the total cost we use to get our marginal cost, right? We differentiate total cost to get marginal cost. We differentiate total revenue to get marginal revenue. We differentiate total product produced to get marginal product produced. So the thing is, total cost is equal to average cost divided by quantity or output produced. This is it. So the total cost is equal to, average cost times quantity produced, or average cost is equal to total cost divided by quantity or output produced. That's basically it, because this is the mathematical explanation or proof for total cost and average cost. Total cost is basically how much cost you earn per good produced multiplied by the total amount of goods you produce. So let's say you incur a cost of 10 naira when you produce one good. So when you produce 10 goods, you incur obviously a cost of 100 naira. Let's say you produce or let's say you earn a revenue of 10 naira per good sold. So if you sell 10 goods, you earn a revenue of 100 naira. So that's basically what these mean. So the total cost is basically the cost of one good multiplied by the total number of goods you produce, and the average cost is basically the total amount of cost you incurred from total production divided by how much goods you actually produced. So you can use this to do justice to this question. Since our average cost function is equal to 90q squared plus 6q plus 17. How do we get our total cost? Remember, we said total cost is equal to average cost times quantity. So what do? We just multiply both sides by quantity or q. So it's just going to be AC times q is equal to q, open bracket, 90q squared plus 60q plus 17. Oh, sorry, plus 6q, not 60q. So AC times Q is just going to give us our TC. That's just going to be, then you expand Q into everything. You have 90QQ plus 6Q squared plus 17Q. So now we have our total cost function and we can get our marginal cost. So total cost is equal to 90Q cubed plus 6Q squared plus 17q. How do you get our marginal cost? Remember, when I say whenever you hear marginal in economics, think derivative. Whenever you hear change in economics, think derivative. So let's differentiate. So we have our dTc by the q, or our marginal cost is equal to, let's differentiate this function. So 3 comes to the back. That's just going to be 3 times 90, then times q, then raised to power 3 minus 1. Remember from the power rule. Then plus 2 comes to the back, 2 times 6 times q raised to power 2 minus 1, back from the power rule. Then plus 1 times 17 raised to power q times q raised to power 1 minus 1. So our marginal cost is equal to 3 times 90, that's 270. So we have 270 q squared plus 12q, 2 6 times 2 12, then plus 17 q raised power 0 is just 1. 17 times 1 is 17. So this is our marginal cost function. In that sense, determine the firm's marginal cost when they produce 15 units of output. So the marginal cost, that's probably when they expanded from 14 to 15, or from basically. So we just plug in our 15 into the marginal cost function. So we have 270 15 squared plus 12 15 plus 17. So marginal cost, you can just put this into your calculator. So let me just simplify. 270 15 squared, that's 225 plus 12 times 15, 10 times 10 100, 10 times 5 50, 100 plus 50 150, then 2 times 10 20, 150 plus 20 170, 2 times 5 10, 170 plus 10, that's 180, I think. So that's 180, then plus 17. So let's simplify. So our marginal cost is equal to 270 times 225. This is 60,750, then plus 192. So our marginal cost is equal to 60,750 plus 172. Sorry, plus 192 plus 192. That's just going to be 60,942. Let's say naira. So when the firm produces 15 units, the marginal cost, the extra cost they incur is 60,942 naira. Yeah, so I mean, this is actually supposed to be 7, so this is 17. So yeah, this is our marginal cost function at 15 units of output produced. So educational question. All right, so let's read the last question. I thought the question was too easy. I didn't read it. So it says excuse me, a firm's total revenue and total cost functions are TR equals 1400Q minus 6Q plus TC equals 1500 plus 80Q respectively. Maximize the firm's profit. This is an interesting question. So it's asking us to find or to maximize the firm's profit, like the profit the firm will earn at the profit maximization point. So how do we find that point? Very simple. Profit maximization happens, if you remember from your micro, is equal to is the point where the marginal revenue is equal to marginal cost. Remember, marginal, whenever you hear marginal in economics, think change, think differentiation, think derivatives. So that's basically it. So how do we find where our MR equals MC? Very simple. Since we have our TR function or total revenue function to be 1400Q minus 6Q squared. Yeah. So how do we get our marginal revenue? Remember, marginal, think derivative, think change. So we differentiate the function. So our marginal revenue is equal to, it just becomes 1 times 1400Q raised to power 1 minus 1 and minus 2 times 6Q raised to power 2 minus 1. So marginal revenue function is equal to 1400, since q raised power 1 minus 1 is 0, q raised power 0 is 1, 1400 times 1 is 1400, and minus 6 times 2, 12, and q raised power 1, or just q. So this is our marginal revenue function. So how do we get our marginal cost? Very simple. Our marginal cost is just going to be, we differentiate total costs. So remember, derivative of a constant is 0, then plus 1 times 80 q raised by 1 minus 1. So our marginal cost is equal to 80. 80 q raised by 1 minus 1. 1 minus 1 is 0, so q raised by 0 is 1. 80 times 1 is 80. So our marginal cost is 80, and our marginal revenue is 1400 minus 12q. So how do we get our profit maximization point? Our profit maximization, this function basically helps us ascertain or determine the number or the level of output that the firm will produce, which will in turn maximize profit. So that's basically what this means. So MR equals MC helps us to ascertain the amount of output that the firm will produce, which will in turn help them maximize profit. Do you understand? So our MR equals MC is just going to be equal to, MR is 1400 minus 12Q. So we have 1400 minus 12Q. That's equal to 80. So what do? We take 80 to the other side and take 12Q to the other side. So we have 1400 minus 80 equal to 12Q. So 1400 minus 80 is just 1320. So we have 1320 is equal to 12Q. So divide both sides by 12, divide by 12. 12 cancels 12 here. So what can we do? We can simplify. Two, or just use our calculator to avoid time wastage. The value Q, or the profit maximizing quantity, is just 1320 divided by 12, and that's 660 units of output. So this firm maximizes profit at 660 units of output. So now how do we maximize the firm's profit? We haven't found the firm's like maximum profit, like the value of profit, or the value of profit, the value of profit the firm will make at this point. So we have to find that point now. This is basically the point at which they will maximize profit, the number of units they have to produce. This is basically saying when will the company earn its most profit. So this is when the company will earn its most profit, when they produce 660 units of output. So that's basically this. So what exactly is that profit? Like how much is that profit is what we are going to find, or what this question is asking us to find. So how do we do that? So remember from your micro too, that profit, or pi, in economics we use pi to represent profit. That's equal to your total revenue. That's total amount of money you gained from selling or producing, or from selling your goods and services, minus total cost. That's total amount of money you spent in producing and selling those goods and services. That's going to give you your profit. So remember, the total revenue function was what? We had 1400Q minus 6Q squared. So that was equal to 1400Q minus 6Q squared. Then minus total cost function. That was basically just Where is it? Um, oh, the total cost even had an extra 1,005 here. Oh, let's ignore that since we already treat. Oh, okay, okay, yeah. Total cost is equal to 1,500 plus 80Q. Ignore me, please. I can be very forgetful or confused sometimes. So yeah, so this is our total revenue. This is our total cost. So how do you get our profit? Just subtract the functions. So pi is going to equal to 1,400Q minus 6Q squared minus 1,500 minus 80Q, right? So this is our profit function. So how do we get the actual value or the maximized profit? We plug in this value of Q into this function. So this will tell us the amount of profits the firm made at the profit maximizing point of output produced. So let me go over it again. This to get our profit function pi in economics represent profit with pi, just going to be TR, that's your total revenue, or the total amount of money you gained or earned from producing or selling goods and services, minus your total cost, that's the total amount of money you spent in the production of those goods and services. So TR minus TC. So that's the TR function or total revenue function is 1,400Q minus 6Q squared. That's what we have here. Then the TC or total cost function is 1,500 plus 80Q. That's what we have here. So we minus that. Minus is going to expand into this. So we have minus 1,500 minus 80Q. So we then plug in the value of Q. Remember, this is a profit maximizing output. That's what we got from MR equals MC. So just plug in that value into the space. So pi is equal to 1,400 open bracket 660 minus 6 open bracket 660 squared minus 1,500 minus 80 660. So you can plug this into your calculator. So let me plug it into my value. So minus 1,500 minus 80. Oh wow, sad, 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 sad. So yeah. So the value of this is equal to 1,743,900. So minus, so this firm is operating at a loss. Wow, that's a lot of money. So they are losing or they are putting at a loss at the end of the accounting period. They are putting at a loss of 1,745 naira. 1,745 naira 900. So this is the loss or the amount of money that the firm recovers or realizes as its profit. Or so it's basically a loss, not a profit. So yeah, so that's basically how we use derivatives in economics. So whenever you hear marginal, think derivative. Whenever you hear change, think derivative. So derivative means to differentiate. So in the next video, we're going to be going over more complex functions and how to use the various rules of differentiation. Thank you for watching to the end and have a wonderful day.